This is the upgraded instrument panel that I've created for Charlie. Charlie was a little sad, with the instrument panel that was stock. It was a simple bar LED display, and it really couldn't really display a heck of a lot other than some error codes and state of charge of then lead acid batteries. So now we have an OLED display that has pretty high res on it, and we have a new bar LED display for state of charge, and a 3-digit 7-segment displays for speed, or error codes as well. So I don't know yet. At the moment, this is just sort of rigged up just to run using an Uno board and the demo software for the OLED. So this kind of just gives you an idea of what this will look like. I've created a plexiglass cover for it as well. It is milled out the slot, and I'll show a little later what that procedure was for doing the milling. One thing that's a bit of a problem is that this molded cover is not perfectly flat where the ellipse cover, plexiglass cover is. So this needs to go in the oven, get heated up so that it can be formed and follow the curve of the cover more. And then there's an overlay that needs to be created so that this doesn't look just plain blue, but will have some descriptive text in there to make it look better. One problem with this display is that it's burning about 2.5 watts, and that means that there's 2.5 watts of heat that has to get rid of at the back. So the resistors around each of the LEDs are getting pretty hot. So I made them intentionally bright. So now I'm going to have to put a gap pad with probably a metal plate in the back. And that's not a bad thing, just to get rid of the heat. The other issue is that this board that is in here now is much bigger than what had been there. So the 2 screws that were original are not enough to secure the board in place, because you can actually see that this is not sitting quite flush the way it's supposed to. So that's the next step, is to 3D print an internal bracket and get the gap pad and another metal plate to help sort of distribute the heat and dissipate it into the air. And then we can say that this is done. It will need a coating of conformal coating when we go to put this full assembly together, but that can happen much later on. There's a lot of code to be written yet for this, and I need the main control board that's going to sit up inside, which is probably, it's either going to be that or the motor speed sensor that I'm going to be looking at doing next. And again, it's things will get done as they get done. Maybe not quite on a weekly basis, but they will get done. So creating the display for Charlie was not as simple as just throwing it together and hoping it worked. There was a lot of measurement made, and the mounting screws that were used for the original display were used as a datum point for lining up the board and creating the milling files to modify the cover. Now, as you can see, the cover itself is not a simple flat shape that's easy to put into one of the micro milling machines. So you really need to put a lot of thought into how you approach the milling. And in my case, because my micro machine was, or CNC machine is very low, like it doesn't have a lot of headroom, I had to flip the cover upside down and get it basically flat with a piece of wood so that I could do the milling. And before I could do that, I had to first create some locating pins that would use the existing screw holes as the datum points. So that helps locate the cover in the XY space of the mill. After milling those holes so that I could put in some metal alignment pins, then I was able to put the cover down, and then I used a little bit of copper tape for doing the Z calibration. So once that's done, then you're able to run the profile to cut the slot and increase the spacing or the size around the 7-segment display. Because originally it had this kind of awkward slots in there that are used to deal with corners or sharp corners so that they can get a very close fit on a square object using a milled hole. I didn't like that. It kind of looks silly, especially since I didn't have an overlay to put over top of it to cover it. So I did clean that up just so that my 7-segment display would actually come through and look proper. And then the milling of the slot for the 10 LEDs bar, that was what was very critical, because it's very easy to make a mistake and then cut into parts of the cover that you don't want to cut into. So overall it did turn out okay, and the fit was good, so as you saw earlier in the video. So thanks for watching, and hopefully this will inspire you to get your Charly back in operation if it's not working.